Hello guys, Prathak this side. Today we'll be doing a LeetCode question which is 202 happy number. So let's first understand what this question is saying. We have to write an algorithm to determine if a number is n is happy. Now what a happy number is a number which starts with any positive integer, replace the number by the sum of the squares of its digits, and we have to repeat the process until the number equals 1, where it will stay or it loops endlessly in a cycle which does not include 1, and those numbers for which this process ends in 1 are happy. And we have to return true if n is a happy number and false if not. So basically what this question is saying is we have to find a happy number, which what we have to do is we have to take the sum where which is 19, n is equal to 19. Now we have to get the square of 1 and 9, and we have to do this again and again until we end up on 1. So in here, as you can see, ends on 1, so this is true, but here it doesn't end on 1, so it is false. So our approach can be, so what the brute force approach can be is, first we will run our loop on it, and we will do it until we find 1 or not, but it won't work because it says the loop and runs endlessly in a cycle which does not include 1. So our loop might run endlessly and it will cause many errors. So in here what we can think is we can think of recursion. Now recursion is what basically is. Recursion is simply a function calling itself. And now why we think of it as because in recursion we can make our edge cases and then make it work for this simple case. Because if it loops endlessly in cycle, which does not include 1, the edge case will take care of that. And if it includes 1, our recursion part will take care of that. So what we'll do is we'll first analyze the question. Now here we can easily say, we can easily observe, like not easily observe, but we can observe that if our n is 1 or 7, it will return in a true. And this was observed if you iterate through, if you iterate through our numbers and do some dry runs on some other numbers, we can easily put this edge case. We can easily take out this edge case, and our second edge case would be if n is less than 10, which does not include 7 and 1, it will be false. And one example of it we can see is here n is equal to, and it turns out to be false. And we can try that also on our other numbers which are less than 10. And then let me just write else. And then we will write our else edge case where we will take a sum, and then we'll run our while loop here, and which will run our while loop till our integer becomes less than 0. So what I'm going to do is here I will take the last value. I'll take the last value from n, and then I will just add it on my sum, add the square of my temp variable in the sum, and then I will just simply divide it so that I remove the last part. And I will just call this function over and over again till I find uh till I find my answer. So mm, so let's try run this question. As you can see, it is passing all the test cases. So let's put one of our old test case here, and we'll just put this. Let's just try run this. As you can see, it is passing our test case. So let's just submit our code here. And the time complexity for is O and log n, and the space complexity for it is also O and log n. Because the number is shrinking the number is shrinking very fast, so the time complexity is very fast, like very optimized, and and the space complexity is also very maximized because of the recursive check here. So that's it from my side. Thank you guys for watching.